Okay, so this is number 12 from your review. Okay. Um, when I looked at these questions initially, they're really good questions for trying to describe what happened from an original graph into a transformed graph. Okay, and then when I sat down to actually look at these are a little difficult to figure out what's actually happened. Um, Having the answers in the back of the textbook made that a little bit easier, but if I were to give you these questions on a test, it would have to be like, first of all, I would count by ones on the grid. But we're just gonna do our best to I suppose maybe explain where the answers came from in the back of the book. Okay, for these questions, not these were tough questions to actually nail down what the transformations actually were, especially when we start talking about horizontal and vertical, and how we could represent either of them using a vertical stretch or a horizontal compression, for instance, right? So a little tricky from that standpoint, and I think that's maybe what makes transformations a little bit tricky. So for question A, maybe it's important to recognize what that graph is, right? So it's y equals the square root of x. And if I were to produce the original points for that particular graph, you'd recall that like I can't input a negative value into this function and receive a valid output, right? And so we have to start at 0, and then we strategically chose a few points that could be easily square rooted. So 1 can be square rooted, 4 could be square rooted, and 9 could be square rooted, right? So I'm going to get 0, 1, 2, and 3. So these would have been the original points on the green graph. Okay, and then we were asked how to find maybe what the equation of the pink graph would have been. When I sat down to do this, I thought maybe your initial, and I bet you your initial inclination was to think, okay, well, the pink graph or the red graph's going to be a vertical stretch of the green one, right? Because it's somehow gotten wider. And so I ran with that for a second, but in theory, if that had been the case, if this y value was 2, which it is on the original graph, right? Then in theory, if I vertically stretch that point should be up here, and it's not. So that was the first clue that we kind of ran into a bit of a problem here, right? So you got to change your perspective now. So maybe the graph isn't vertically stretched by some factor, or maybe it is, but very difficult to identify what it is. So change your perspective. Maybe it's not, it could be vertically stretched, but maybe it's horizontally stretched by a nicer number, right? Or compressed, sorry. So if I'm looking at that point, that 4-2 point again, to me, I think that point got transformed to here, where we've got a value of 1. And so I think that red graph has been horizontally compressed by a factor of 1/4. Right? We took the x values and cut them into 1/4, right? So I think this graph here, if I was to write out the transformed graph, I'm just trying to think what to call it. We're going to call it g of x. We'll just call it g of x. That didn't need to be that hard. G of x is going to be 1/4. Sorry. Remember, on the inside, what you expect is always the opposite. Okay, so that says that's been horizontally compressed. Okay, by a factor of 1/4. Okay, so that's that graph. That's how you would produce that, I think, right? Now the next one, again, just with the scale of the axes is a little difficult to see, right? So I'd say for sure some sort of reflection has happened, right? And on the test, I'd probably give you some questions that you could easily identify, right? So we know this graph is the reciprocal function, so 1/x. And we know that the green one is going to be the base graph, right? So when I input a value of 1, let's say, that's going to be my benchmark, I think, is that point 1. When I input 1 and -1, right, my outputs are going to be Like if I have f at 1, I'm going to get 1 over 1. And when I get f at negative 1, I'm going to get 1 over negative 1. So those 2 points, so when x is negative 1, y is negative 1, that's that point right there, right in the middle of that 0. And the other one is going to be positive 1, 1. Okay, what we need to figure out is how these points have changed. Okay, which is, again, this is a difficult question to identify what that vertical stretch or horizontal stretch or vertical stretch is. It's difficult to find out what that factor is. But just identify 1 or 2 points on the graph and try and figure out where they went, right? So to me, these points have obviously been moved over to here somewhere, right? So for sure, some sort of reflection has had to have happened. Now, I think it could have very well been, because of the nature of this graph, could have been a vertical reflection as much as it is a horizontal reflection, right? Now, in the back of the book, they've put it as a horizontal. So that means for this question, they're going to have something like y equals 1 over negative x. Okay, but that doesn't get us to the final graph. Some sort of stretch or compression has had to have occurred in order to get that point so far away from the origin, right? So how much did it stretch by? That's a little difficult to see. But we would have gone from here, if I reflected it, to there. So what's that measurement? Well, on the back it says it's been horizontally stretched by a factor of 5 is what they've written. And the way that they've represented that as that's how they've represented this. Okay, again, the transformations with the reciprocal function are a little bit difficult. We're going to do a whole bunch of this. We're going to look at this graph pretty in depth. But I think for our transformations test, we're just going to strictly look at maybe like the vertical stretches and compressions and whatnot, or we're just going to deal with the 3 functions like y equals x squared, y equals the absolute value of x, and y is equal to the square root of x. This is difficult to figure out by how much this has been stretched or compressed, right? Unnecessarily difficult, right? And so what we're going to do is just concentrate on the vertical stretches and compressions. We're going to concentrate on these 3 graphs. However, this is totally valid, this particular graph. So the reciprocal graph, we can translate very easily by keeping track of, as you can recall, we can keep track of where these asymptotes are. Okay? So if I translate the graph left and right and up and down, we can track that movement using the asymptotes, but the stretches are a little bit difficult to see. Okay, and so somewhere that point is now turned from 1, 1 into negative 2 and a bit, right? That's going to be hard to see. Okay, so that's that. I wouldn't stress too much about this particular question. However, it is important to be able to recognize at least something has happened, right? Like the big idea there is some sort of reflection has occurred and some sort of stretch or stretch has occurred as well, or compression, I suppose, if you're thinking horizontally. But anyway, that's that. Maybe it's a little bit of a difficult question, right? But this is okay. Okay, question A. Question B is a little bit trickier, but anyway, that's that.